Okay, Algebra 2, we've got lesson 513. Take a look at the top here. It says, review radical 119 times radical 119. You don't even need a calculator for this. And that might surprise you at first, but that's why we're reviewing what we did last week. Radical 119 times radical 119, what do you think that's going to equal? By the way, here's the hint. I really have two of the same factor, and I could put them in one radical. I could say this is, now I don't even have to write this out this way. I could say, look, it's like having one radical with 119 and 119. What do you think we can do now? We'll take out that number. Whenever we've got two of the same thing, we could just take that out. There's nothing left. It's just 119. So whenever you have two of the same factor, guys, you can just take that out of a square root. You can think, well, why are we even talking about that? Well, today we're going to use that idea. Look at this learning target. I can rationalize the denominator. Now, guys, here's what you first and foremost have to be aware of. We're not going to consider an expression to be simplified if we have a radical down below. So if I have a radical 5 down below, I don't want it there. I want to be able to not have it there. And here's what we're going to do. I've only got one radical 5. I'm going to multiply the top and the bottom by radical 5. Now the top becomes 3 radical 5. Down below, it's just like this problem that we had for our warm-up. Guess what radical 5 times radical 5 is going to get you? Just a 5. And we are done. You now have two radicals with the same factor. It's like you can just take that factor out of the radical. Here's what's so important. This new answer, this final answer, doesn't have a square root in the denominator. That's why we're going to consider it to be finished and to be good. So let's take a look at example 2. The problem, of course, is we have a square root of 2 down below. We don't want that. Guess what I'm going to multiply to the top and the bottom? Square root of 2. Up on top, I'll get 10 radical 2. Down below, I've got a root 2 and a root 2. Guess what I'm going to have? A 2. However, we should always check our final answer just to see if we can reduce or simplify. And we can. 10 divided by 2 can be worked out. That's just going to be a 5. Your final answer is going to be 5 radical 2. Okay, so we're going to have some problems like that too, where after you multiply by your radical on the top and the bottom, you might have to simplify it. Talking about simplifying, this 14 over 6, I do want to tell you, you'll get some problems like this where, tell you what, we could just reduce this fraction immediately. We could type in 14 all over 6 here. 14 over 6 is really 7/3. So this thing is really 7/3. If you can simplify a fraction inside, you're always welcome to do that. Your calculator can be used to help you out. Now, the next thing I want to show you is, even though you see a fraction inside, and we've talked about this a little bit before, this is really the same problem as radical 7 divided by radical 3. But here we go again. You don't have a final answer that you want to have right now because you have a square root in the denominator. So I need to do what I had done in the previous two problems. I want to get rid of that radical down below. What do you think I'm going to multiply to the top and the bottom? Square root of 3. And kids will say, why are you doing that? Well, now I have 2 radical 3's down below. What's radical 3 times radical 3? Just a 3. Here's the big difference. Now in my new answer here already, you can see I don't have a square root down below. That's what we want to have happen. How about up on top? What's radical 7 times radical 3? That's radical 21. One final question. Do you think I could simplify that and make that 21 over 3 and make it 7, do you think? No, because one number's inside the radical, the other one is not. If I just gave you 21 over 3, that would become a 7. But here, one number's inside a radical, the other one is not. Okay, we've got 3 final problems to take a look at. Different learning target. I can solve a quadratic equation. How? You can see up at the top, finding square roots. So here's what's going to happen. We're going to take our square roots, but guys, there are 2 square roots. Last week when we said find all the square roots, you might remember there was a positive and a negative. That's what the plus minus means. The plus minus means there's a positive square root and a negative square root. Now, I hope you remember what the square root of 25 is. What's the square root of 25? 5. Kids are saying you're absolutely right. How would you type it into Alex? Well, you'd go 5, comma, negative 5. Alex requires us to separate answers with commas, right? Okay, well, we're almost done. We have to take a look at a couple more. For number 5, you can say, well, isn't this kind of like exactly the same thing? We'll have plus or minus the square root of negative 16. But I think some kids, I can tell already, you're not too happy about that. What do you think's going on here? No real root here, no real number. And you can think, well, why not? No real solution, you could say, no real number. Why? The square root of something negative. If you're ever forgetting that, if you're wondering about that, you could even type that in. Square root of negative 16. What number times itself is negative 16? None. It's not negative 4. A lot of times kids think it's negative 4. But negative 4 times negative 4 is not negative 16. Okay, one last one. We're going to take our 2 square roots here, but this is where stating the obvious, 24 is not a square root. Kids probably want to stop right here and say, okay, I'm done. But you can reduce this. You might remember last week we talked a lot about simplifying or reducing square roots. You could make a factor tree or you could make a division tree. Work with primes. The prime numbers were 2, 3, 5, 7, and 11. You know, I make an upside down division tree and I could say, well, start with the smallest one. Start with the 2. 24 divided by 2 is a 12. Then what? Well, 6 isn't prime, though. You see, we go back to the 2. And 12 divided by 2, you'd get a 6. And then you'd say, well, try a 2 again. Keep going with 2 until you're done. And again, some teachers call this the hockey stick method because it looks like you got a hockey stick right here. But it looks like we've got 1, 2, 3 2s, and also a 3. And remember, there's a plus minus here. You're looking for how many of the same number? 2. You're looking for doubles, right? And whenever you've got doubles, you can take one of those out, ignore the other one. What's still inside? Well, the 2 times 3, that's a 6. So you're going to have 2 answers. You'd go 2 radical 6 and negative 2 radical 6. And guys, that's all you got to do for today's work. Okay?